All right, this is Algebra lesson 10.2. Are you guys ready over there, or you're not ready yet? Simplifying radical expressions. Okay, here's the deal. I'm going to show you some basics. The square root of x and y, are you paying attention? The square root of x times y is the same thing as the square root of x times the square root of y. I just need you to understand that concept. Okay, does that make sense? I mean, that should kind of make sense to you. I'll tell you right now that multiplying or that dealing with this with square roots is very similar to dealing with them as though they were variables. Just kind of keep that in the back of your brain. There's a lot of similarities here. Here's the deal. If I have the square root of 80 and I tell you to simplify that, okay, first of all, I just dealt with this with the 7th graders in pre-algebra. What is this called? Is that rational or irrational? Do you remember? It's irrational. Why is it irrational? Give me a better answer. Why is it irrational? What's the difference between rational and irrational? What is the square root of 80? What is the square root of 80? You should have calculators here. You're going to need them. What is the square root of 80? It's just 8.9? Keep going. What is it? 8.49, and then it goes forever, right? 8.948. So hold on. Wherever your calculator stops, if you took that number, wherever it stopped, and you multiplied that exactly by itself, would it equal exactly 80? No. Okay? So what if you kept going? What if you kept the decimals going way out there, and wherever you decided to stop, a million decimals later, if you took those and multiplied it exactly by 80, or not by 80, by itself, would it equal 80 exactly? No. In other words, there's no end. There's nothing that you can multiply by itself to make 80. Therefore, it's irrational. Right? Therefore, it's irrational. Which means that, the best answer is a square root of 80. That's the best answer. But you can simplify this. Here's how you do it. Are you ready? I'm going to show you how to simplify it. You're going to break 80 down into perfect squares. You're going to break it down into factors that make perfect squares. For example, 80 can be, let's do prime factorization. 80 can be 8 and 10. Do you agree? Right, 8 and 10. 8 is 4 and 2. Ooh, I see one here. Do you see what I'm saying? 4 is a perfect square. What is the square? So listen, here's the deal. What I can do is this. It's the square root of 8 and the square root of 10. You see what I'm saying? Remember what I told you, the square root of x, y is the same thing as the square root of x times the square root of y, which means that the square root of 80 is the same thing as the square root of 8 times the square root of 10. Do you see what I'm saying? Okay? And so the square root of 8 is the square root of 4 times the square root of 2, right? Well, wait a second. That one, what is the square root of 4? 2. I can cross that out and pull out a 2. You see what I'm saying? Okay. What about the square root of 10? Can I break the square root of 2 down anymore? No. What about the square root of 10? That can be the square root of 2 and the square root of 5. Can I break down the square root of 5 anymore? No. But here, let's talk about this. What is the square root of 2 times the square root of 2? 2. Right? It's the square root of 4, which is the square root of, which is just 2. So whenever you have a pair here, square root of 2 times square root of 2, that brings out another 2. You see what I'm talking about there? So now I've got 2 times 2 pulled out, and the only thing I have left is times the square root of 5, which is 4 times the square root of 5. Now let's do this. Let's do the math here. Let's make sure we did this right. What is the square root of 80 roughly again? It's just about the number 9. Agreed? It's just about the number 9. What is the square root of 5 roughly? Somebody look it up. 2.2. What is 4 times 2.2? Roughly? 8.9. Roughly 9. It's the same thing. The square root of 80 and 4 times the square root of 5 is the same thing. This one's just simplified. Does that make sense? Does that make sense? Okay. You guys try one. Do the square root of, we'll do one, we'll do 75. Do the square root of 75. Simplify that. Okay, so here's the deal. This is what I would do if I were you. You could break this down into the prime factors if you want to. That would be, now listen, technically when you do this, you're going to go the square root of 25 and the square root of 3. Right? Does that make sense? If you understand that, then you could go 25 and 3 and just know that it's the square roots. Does that make sense when you do it? But whatever. Let's do it right. Okay. Ooh, right there. What do you recognize? That is a perfect square. Right? So then you go, okay, I can pull out a 5 and all I have left is times the square root of 3. I'm done. 5 times the square root of 3 is the square root of 75. Does that make sense? How many of you got that? 3 times the square root of 5. Or 5 times the square root of 3. Does it make sense? Do another one. Square root of 60. Do it. Because what's the square root of 25? Does that make sense? You break it down into square roots that are perfect squares, and the key is boom, boom, pull it out. Boom, pull it out. So, the square root of 60, I ask you to simplify it. I'm going to break this down into, listen, you can break it down completely into prime factorization if you want to. In fact, let's do it that way. I'll do it both ways. One, you go, okay, 30, square root of 30, and the square root of 2, right? He's done. Which is square root of 2 times the square root of 15, done. Square root of 3 times the square root of 5, right? Done. I'm done. That means that I have that the square root of 60 is the square root of 2 times the square root of 2 times the square root of 3 times the square root of 5. Agreed? Right? What can I do here? What is the square root of 2 times the square root of 2? 2. What's the square root of 2 times the square root of 2? It's the square root of 4. What's the square root of 4? 2. Right? So that's gone. That gives me a 2. And then I can't, that doesn't do me any good. There's nothing else to combine. So what is the square root of 3 times the square root of 5? Square root of 15. How many of you got that? Wow.
Square root of 3 times square root of 5.
No, got to break it down. Once you unbreak it down, we're making this simple. That's not simple. That's the most simple. 2 times square root of 15. Try another one. Square root of, we'll do 40. All right, you're going to break this down into the simplest square roots there are. This would be, you could do, 4 and 10. Square root of 4. Why you want to grab 4? Because that's an easy one, right? You know that's just going to instantly turn to 2, right? Because, listen, 4 times 10 is 40, right? We're just breaking it down. Oh, okay. We're going to cross this off, bring out the 2 right here, right now. Make sense? Okay. Square root of 10 is the square root of 2 times the square root of 5. Ooh, we're done. Can I do anything with that? I mean, is there anything to pull out of that? No. So you're going to go put it back up here to the simpler one, which is 2 times the square root of 10. How many of you got 2 times the square root of 10? Does it make sense yet? Not yet at all? Okay, you're doing this one. You're going to end up doing this whole one. Here we go. Square root of 120. Break that down. It's called simplify. Here we go. Here it is. Listen. If you're having trouble with this, pretend that square root symbol doesn't exist. And do the prime factorization of 120. 12 and 10. 4 and 3. 2 and 2. 2 and 5. 2, 2, 3, 2, 5. Right? Except we're not going to do that. Every one of these things had a square root symbol. Right? So then it comes out to square root of 2 times the square root of 2 times the square root of 2 times the square root of 3 times the square root of 5. What is 2 times the square root of 2? Square root of 4. What's the square root of 4? 2. So right now, the square root of 7 times the square root of 7 is square root of 49, which is just 7. So you just need to memorize that. The square root of a number times the square root of that same number is the number not being square rooted. Square root of 17 times square root of 17 is 17. The square root of 56 times the square root of 56 is 56. Does that make sense? So the square root of 2 times square root of 2 is 2. They're gone. That leaves me with a 2. And now you're looking for pairs here. Can 2, 3, and 5? Nothing. 2 times 3 is 6. 6 times 5 is 30. 2 times the square root of 30. How many of you got 2 times the square root of 30? Are we following this yet, Lauren? Are you working on it every time I give you one? Just making sure. Try another one. Did you pay attention when I went over this, though? I mean, I saw you looking down. If you're not paying attention, how could you learn if you're not? All right. You should be up here, though, too, right? Don't just listen. You're up here. Square root of 90. All right, here we go. You're watching. 425. I'll break it down. I know that if it's 425, it's divisible by 25. I know that. Right? I know it. But whatever, even if you didn't, and you know that it's, and you just look at it and you know it can be divisible by 5, you divide 425 by 5, what do you get? 85. So you go 5 and 85. Square root, square root. You know this is also divisible by 5, so what's 85 divided by 5? The square root of 5 and 17. What is the square root of 5 times square root of 5? And 17 is prime, so you know that thing's done. 5 times square root of 17. How many of you got 5 times square root of 17? Okay. You didn't get it, Bubba? Do you understand what's going on, or do I need to go through this with you? Okay. Something else. What about this? These are the kind of weird ones. What if I have the square root of 2 times the square root of 14? And I said, I want you to simplify this. Okay, so this is what you do. It's just one extra step. You have to put them together into one and then undo them. Or you can just keep undoing them, right? Just undo everything and then combine them. You know what I'm saying? Like, you can do whatever you want to here. The wise thing is just to undo everything and then combine what you can. See if you can figure it out. I'll show you in a second. Like I said, 2 ways to do this. There's the hard way. There's a way that you can wrap your brain around this easy. Then there's the, you could combine that. What is square root of 2 times square root of 14? You could break that, go square root of 28. And then you go, okay, that would be 2. Oh, you're back to square root of 2 times square root of 14. Do you see what I'm saying? You see what I'm talking about? And then you go square root of 2 times square root of 7. Square root of 2 times square root of 2 is 2 times square root of 7. What you should have done right from the beginning is just broke 14 down to square root of 2 times the square root of 7. And then you go, oh, square root of 2 times square root of 2 is 2 times the square root of 7. How many of you got 2 times the square root of 7? Does it make sense? Okay. Let me give you one that's a little more. What is the square root of 6 times the square root of 8? Try that one. Square root of 6 times the square root of 8. So what can you do here? Listen, does it make any sense to actually combine them into square root of 48? It doesn't. You know why? Because when you undo it, what are you going to undo it to be? 6 and 8. Or you could, right? So then you're like, oh. All this is already kind of halfway done for you, right? It's broken down for you. So then you go, okay, this is the square root of 2 times the square root of 3. And 8 is the square root of 2 times the square root of 4. If I see the square root of 4, I instantly go, boo! Right? Boom. Gone. That becomes a 2. Right? Okay. Then I have a square root of 2 times square root of 2, which is another 2 times the square root of 3, which is 4 times the square root of 3. Does that make sense? Yes, Big John?
So, I still have that right, but, I wouldn't, so it's multiplied, you don't add them, you multiply it.
Right. Right. You couldn't have got it right if you added them. That makes no sense.
No, I mean, once I got the square root of 4, I did 2 plus 2, not 2 times 2.
Oh, well, that was just lucky that it was 4.
Yeah, so.
You know what I'm saying? If it would have been 9, that would have made no sense.
Yeah.
Okay. I'm going to give you one sample of a big one. Okay, here we go. This is the sample. It is the square root of, well, hold on. Let's do this. X squared y to the third. I'm going to show you this. Okay, I'm going to show you this. I could break this down, can I not? Could I not break this down? If I wanted to break this down, how could I break this down? I could go square root of x times the square root of x times the square root of y times square root of y times the square root of y, right? I mean, eventually you're going to get to the point where you don't need to do that. But, okay, what is square root of x times square root of x? X. What's the square root of 3 times the square root of 3? 3, right? So the square root of x times the square root of x is x. They're gone. And then the square root of y times the square root of y is y. And then that leaves me with times the square root of y. Does that make sense? Now here's the tricky part. If the number that is on the outside, if you are pulling out an odd number of variables, okay? Here, I pulled out a single x and I pulled out a single y. You understand what I'm saying? That means that that could be plus or minus, right? What is the square root of 16 again? It's plus or minus 4, right? Just like with this, since this is actually the square root of x squared, when I pull that out, it could be plus or minus x. Does that make sense? So here's the rule. If I am pulling out an odd number, that's x to the first and y to the first, guess what? Both those babies are in absolute value symbols. It's plus or minus. You have to put the answer in absolute value symbols. If I did this, if I had the square root of x to the fourth, y squared, or y to the third, we'll say. Are you guys gone? I love you. Yes. X by dot dot. X to the fourth. What do I, when I pull that out, listen, what is the square root of x to the fourth? You should just know. What number times itself makes x to the fourth? X squared, right? X squared times x squared makes x to the fourth. That is an even number. Do you agree that that is an even number? I don't have to put that in there because if it's an even number, what if it was a negative? What if that x was a negative? You know the answer is going to be a positive because it's being squared. Does that make sense? But when I pull out the y, I'm going to pull out a y. I'm only going to pull out one y, leaves me times this. That has to be in absolute value symbols because the y is just by itself. Do I need to break that one down all the way? I will. This is x, square root of x, times square root of x, times square root of x, times the square root of x. Right? We all got that? Times square root of y, times square root of y, times square root of y. What is square root of x times square root of x? Plus or minus x. It's true. That is plus or minus x, right? So that actually is, that's plus or minus x. I'm going to put that down. Plus or minus x, pulling that out. And then here, when I do it again, there's two more x's. What is that? That's also plus or minus x. Do you agree? Right? So I've pulled those out. They're gone. And now I pull out a y. What is square root of y times square root of y? That's a y. That's plus or minus y. Do you agree? That's plus or minus y. And then it leaves me with just, times the square root of y. Now let's talk about this. If these guys were both positive, then it's a positive because x, if it was x times x, it'd be x squared. If they were both negative, then it would be negative x times negative x, which still make it positive. Does that make sense? So if it's an even number out here, then this is just going to be x squared. I don't need to put it in absolute value because it's just positive. If it's an even number being pulled out, you leave it positive. If it's an odd number, like this one here, that could still be negative y. Does that make sense? Now, if you want to get technical, it can't be negative. Do you know why? Because that would leave this guy in here negative. Does that make sense? And can that be negative inside of a square root symbol? No. Right? Anyway. You still would, no, you don't put the plus or minus. You'd go x squared times this absolute value of y times y squared. That's what you'd do. Does that make sense? I showed you that so you'll have another. What about this? One more thing. Listen, I'm not giving you any. I'm going to give you some homework, but it's going to be over the basic ones. I'll just show you one more kind. This right here. What about this? The square root of 35/15. I'm going to erase that so that it looks nicer. Oh, it's a square root of a fraction. Okay. Here's the deal, just like with multiplication, the square root of 35/15 is the exact same thing as the square root of 35 over the square root of 15. Does that make sense? Same thing. Here's the rule. You ready for the rule? You are not allowed to have your denominator. Which one's the denominator? The bottom cannot have a square root symbol. Okay. So then what can I do to multiply this thing by 1, right? Because this thing's just a fraction. I need to multiply it by 1 in a form that will allow me to not have the denominator having a square root. What can I multiply this thing by to make it so that the denominator is not going to have a square root? I have to multiply by 1. In what form? Not 15 over 15. 1 over 1 wouldn't do any good because then it's still the square root of 35 times square root of over the square root of 15. Multiply it by the square root of 15 over the square. What is the square root of 15 over the square root of 15? Right. Anything over itself is 1. So now what's that going to allow me to do when I multiply this? What is the square root of 15 times the square root of 15? What's the square root of 15 times the square root of 15? 15. That now becomes 15. And the top is the square root of 35 times the square root of 15. Can you do that? Didn't we just learn how to do that? Break it down, right? That would be the square root of 7 times the square root of 5 times the square root of 3 times the square root of 5. Square root of 5 times square root of 5 is 5 times, square root of 7 times square root of 3 is 21. 5 times the square root of 21 over 15. That can be reduced, the 15 there can be reduced to 1/3, which can be reduced to the square root of 21 over 3. I showed you that so that you'll have an idea when we do this tomorrow, because we're doing this tomorrow. It will not have been the first time you've seen it. Your homework tonight. One more thing I'm going to show you really quick. It's important. What if I gave you this? You know how I did this? Square root of 2 times the square root of 14? What if it was 2 times the square root of 2 times 14? What would happen here? What if it was 2 times the square root of 2 times the square root of 14? Look. You still go 2 times the square root of 2 times the square root of 2 times the square root of 7. Do you agree? Does that make sense to everybody so far? For real, do you look up there and go, that makes sense completely? Okay. What is the square root of 2 times the square root of 2? 2. So that means you pull out a 2. That means that it's 2 times 2 times the square root of 7, which is 4 times the square root of 7. Does that make sense? It's already out there. The 2's just already been pulled out. That 2 has just already been pulled out. Okay. Really quick then. What about 2 times the square root of 2 times 3 times the square root of 10? Let's look. It's all being multiplied here, right? So if you need to break it down, you go 2 times the square root of 2, or 2 times the square root of 2 times 3 times, how can I break down the square root of 10? Times the square root of 2 times the square root of 5. Okay, that's already out, that's already out. They're gone. Let's bring them down. That's the square root. That's just 6. You agree? And square root of 2 times square root of 2 is 2 times 2 times the square root of 5. 12 times the square root of 5. Does that make sense? All those things have just already been pulled out for you. That's why it's no big deal. We'll do this then. We'll go we're on page 615, 1 through 6 all, and 17 through 25 all. That's the ones I want you to do for your homework tonight.